Hi everyone, welcome to the first lecture for Architecture and Operating System module. I'm going to go through the first worksheet, which is already available on the Moodle. Please watch the series of these videos and go through the worksheet and solve all the problems and exercises at the end. So binary numbers, but before we start talking about the binary numbers, let's go to very simple and basic thing that I'm sure all of you know, but just a quick recap about this. When you're talking about a number like 2, 3, 4, 5, 6, 7, sorry for my handwriting, I'll do my best to do a better job. So what does it mean? 2345.67. As you know, we call it decimal system. In decimal system, each digit here is meaningful. It's got a meaning. For example, for the first one is for the ones. Here is for the tens. Here is for the hundreds. And here is for the thousands. And the rest I will explain that. So guys, when you're talking about decimal number, it means that each place, hundreds, ones, tens, whatever, can have up to 10 numbers. You can have a choice between 0 till 9. 0 till 9. It means that we can put 10 numbers there. Because of that, we call it decimal. So in the first place that we have ones, it means that we have 10 options. This is 10 to the power 0. 10 to the power 0 is 1. When we are going to the second place, this is tens. It means that 10 to the power 1, which is 10. When we are talking about this third place, it's 10 to the power 2, which is 100. And when we are going to the thousand, it's 10 to the power 3, which is 1000. So here, as you see, we have 2 of these 1000s. We have 3 of these hundreds. We have, oh, this is 4, yeah? Let me delete that. There you go. We have 4 of these tens, and we have 5 of these ones. Also, we have 6 of, for this specific actually place here, this is 10 to the power minus 1. And here is 10 to the power minus 2. So we have 6 of 10 to the power minus 1 and 7 of 10 to the power minus, oops, there you go. Let me delete that. Come on, minus 2. So as you see here, let me add this number. This is 2000. This is 300. This is 40. This is 5. This is 0.6. And this is 007. If you add all of them, which is 2, 3, 4, 5, 6, 7. So in the decimal place, in the decimal system, sorry, in the decimal system, each of these places shows a tens. I mean, that's a power of 10. Here is 10 to the power 0, 10 to the power 1, 10 to the power 2, and 10 to the power 3, which is decimal number because we've got 10 numbers, 0 till 9, which is 10. So this is how we can convert a number. We can actually use this decimal system to show the numbers. But the question, can we use this system for computers? Let me do a proper question mark for you here. Can we use that for computers? No, we can't. Why we can't use that? Because computer works based on another system. In computers, what we have, we've got signals. Computer works based on digital signals. It means that the signal is high or low. When the signals are high or the voltage is high, we consider that's an abstract thing. We consider that's 1. When we have low voltage, we have 0. Everything that we have in computers In data communication, everything is based on these voltages and based on the signals that we have only two values. So it means that we are looking for a numerical system which can represent only by two numbers. So in the decimal system, as I told you, we have 10 numbers, 0 till 9. But now we are for computers, because we've got only high and low voltage, we have 1 and zeros, we are looking for a system to be able to represent these numbers. This numerical system, which got only two values, which is 0 and 1, we call it binary. So I'm looking for a system to be able to present this. So as you see, if you have a number, we have only two values, 0 and 1, 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 and then go. As you see here, we have only two options for each place, similar to what we had up there. As you see, we have 10 options, 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3, which shows we have ones, tens, hundreds and thousands, and go. Here, again, we've got similar thing. We've got 2 to the power 0, 2 to the power 1, 2 to the power 2, 3, 4, 5, 6, 7. 2 to the power 0, I'm sure you know that. This is 1. Let me scroll down a bit. 10 to the power, 2 to the power 2 is 2, 2 to the power 2 is 4, this is 8, this is 16, this is 32, this is 64, and this is 128. Guys, each of them here is called a bit. It's like letters. In any languages, we've got letters. When you put the letters together, we have a word. If you put 8 of these bits together, we call it byte. Let me write it like that. We call it byte. This is the word for a computer. This is the letter for a computer. Each place can have two numbers, 0 and 1, 0 and 1. But when you put it in this order in a byte, so the first one is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, till 2 to the power 7. And these are the values. So the question, how we can convert a number from decimal to the binary? Let me give you an example here. Oops, example. How we can do this? So, look guys, it's a very simple thing, easy job that you can do. I explain you, for example, a number. If you have 25 and we want to convert it to, this is decimal, I want to convert it to binary. How I can do that? So as you know, I said that we have a word in computer which is byte. Each of them has got two values, 1, 2, 3, 4, 5, 6, 7, 8. So 2 to the power 0, which is 1, 2 to the power 2, 1, sorry, is 2, this is 4, this is 8, this is 16, this is 32, this is 64, and this is 128. Okay, cool. Now, what I'm going to do, I have to convert 25 to binary. So what we can do, we can say, okay, where does this 25 go? The 25 is certainly between 32 and 16. So can you have any 32 in 25? Nope. So it means that here we have 032, 064, and 128. But we can have 116 from 25. So 25 minus 16 is what? 9. 9 is the remainder. So go to the next place. Do you have any 8 in 9? Yes, we can have 1 8 in 9 because 8 is less than that. If you subtract that, 1 remains. Do you have any 4s in 1? Nope. This is 0. Do you have any 2 in 1? Nope. 0. Do we have any 1 in 1? Yes, we have 1 in 1. So 1 minus 1, which is 0. The remainder is 0. We stop here. So it means that 25 is equal with 11001 to the base 2. This is equal with 25 to the base 10, or simply we write 25. When numbers are in the base 10, we don't write it, we show it like that. But if it is base 2, we do it in this way. So as you see, 11001 is another way of representing 25 in binary system. But another example, if I have a number, I want to convert it back to decimal. If I have another number, for example, if I have 1010 and I want into the base 2, I want to convert it to decimal. How to do that? So guys, as I told you earlier, here is the place for 1, here is the place for 2, 2 to the power 1, 2 to the power 2, 4, and 2 to the power 3, 8. So as you see, we have 1, 8, we have 0, 4, we have 1, 2, that's it. If we add these two numbers together, we get 10. So as I showed you, this is the way we can convert binary to decimal and decimal to binary. So we have another way of representing a number. We call it hexa. What is hexadecimal or hex? Hex. I want to explain this as well. Hexa. Hexadecimal. Hexadecimal is number to the base 16. Decimal is base 10. Binary is base 2. The hexa is in base 16. When I say base 16, it means that in each place, in each location for a number, we should have 16 values. What are those 16 values? Okay, I know that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is okay, we've got 10. What about the rest? We need to have 10, 11, 12, 13, 14, and 15. Now we've got actually 16 values that we can put in each place because that's base 16. But how we can represent 10? We show it by A, we show it by B, C, D, E, and F. There you go. So in hexa, we have values from 0 till F. As simple as that. So for example, if you have a number, let me scroll down a bit. If you have a number, for example, I have D, 3, C, and E. This is in base 16. I want to convert it to what? To decimal. How I can do that? Look guys, I told you the first place is always base to the power 0, second place base to the power 1, base to the power 2, base to the power 3. So what is D? D is what? As you see here, D is 13. So I have 13 times 16 to the power 3. What is 16 to the power 3? Let me cheat, use my calculator. 16 times 16 times 16. This is 4,000. 16 to the power 3 is 4,000. 0.96. Also, I have 16 to the power 2. What is 16 to the power 2? Is 16 times 16. Is 16 times 16, which is 256. I have C, which is 12 here, as you see. This is 12 times 16 to the power 1, which is 16. Let me scroll down a bit. And last one, which is E. E is 14. 14 times 1. So if you actually get this number, 13 times 4096, it gives us, where is the my mouse? sorry, 13 times 4096 is 5302.48. 3 times 256, 3 times 256 is 768. 12 times 16, just simple calculations, is 192, and I have 14. If you add them, I believe that we get 54222. So guys, this number D3CE in hexa system is equal with 54222 in decimal. So how we can actually convert the decimal to the hexa? That's very simple. Let's do it, for example, very simple number that we can do. Let's go for converting, where is the, here. Now decimal to hex. For example, 54, very simple thing. I know that in hexa, here is 16 to the power 0, here is 16 to the power 1, here is 16 to the power 2. So 16 to the power 1, 0 is 1, this is 16, 16 to the power 2 is 256, but let me double check, 16 times 16 is 256. So 256. So guys, how many, do we have any 256 in 54? Nope, so it means that from here to the left is 0. How many 16 do we have in 54? 54, if you divide it by 16, you get 3.3 something. It means that we have 316. 3 times 16 is 48. If you subtract that, 48 from that, we get 6. And we have 6 ones there. So it means that 54 in decimal is equal with 36 in hexa. If, for example, we had here 13 instead of 3, so what you had to do, you had to say this is D. 13 is D. So it depends on the values that you have here. So guys, this is the way that we convert. Actually, I discussed what is decimal, what is binary, how to convert decimal to the binary, binary to decimal, decimal to the hexa, and hexa to binary. Hexa to decimal. So guys, if you wanted to convert hexa to binary, so the easiest job is to convert all of them into, actually convert it to the decimal, and from decimal, convert it back to hexa or vice versa. I hope you enjoyed your first lecture. Please watch that. There are some exercises in the worksheet, and I'll go to the second video, which is about binary arithmetic. Thank you.